Hello, my name is Mr. Jason, and I'm from the library at Collister. I'm here to teach you a little bit about my favorite subject, engineering. And today, I'm going to focus on explaining the difference between tension and compression. And then, we'll do a couple fun activities involving both of those forces. Compression and tension are often called the push-pull forces because they result from an object pushing or pulling against another force like gravity. For example, this water bottle can act like a column when I push down on it. The water bottle is resisting my push, and it is actually pushing back against my hand, resulting in a compression force. If I were to take a piece of string and I tried to push down on it, it doesn't resist the push of my hand. This string doesn't provide any compression force at all. However, if I were to hang an object from the string, it would then resist that pull of gravity and it would pull the object in an upward direction. And that is called the tension force. One of the most important objects in engineering is called the truss. This is a very simple truss design, and it is used to demonstrate the redirection of the tension and compression forces. In this example, if this were a bridge or any other load-bearing object, there would be weight here and gravity would be pulling down on the whole object here. But some of these pieces will pull and some of these pieces will push back against any weight that is applied. Most of this weight right now is being applied to these top beams. We can see this if I were to replace these beams with this piece of string. Now, as soon as I let go, all of the weight of this bridge will be applied to where those beams were, and since the string cannot provide a compression force, we'll see what happens. It just collapsed under its own weight. One thing that is interesting about the truss design, though, is that based on how the weight is applied, different pieces will be in compression and different pieces will be in tension. As we saw before, right now the string, or the area where the string is located, is trying to be under compression, but the string cannot resist it. If we were to flip this upside down, now all of that weight that was pulling on this area before is now pushing on this area, which means the string is being pulled tight down here at the bottom. So rather than collapsing under its own weight, the string can actually help support loads like this water bottle. Now, solid objects too, like the beams that we removed earlier, can also apply that tension force. So you might be wondering, why would we use string at all? Well, in many cases, string can be helpful and especially much cheaper than the solid objects we're using in these components. Now, I would like to show you a couple exciting activities that we're going to do, building bridges and a cool piece of engineering called tensegrity. But we're going to need some popsicle sticks, some string, and a table. So let's go find a room with a table. Now that we've found a table, we can go ahead and begin our first project called the Da Vinci Bridge. This is a bridge that will stand up under its own pressure without the use of any glue or tape or nails. Now, you can use any objects such as pencils or chopsticks. I'm going to go ahead and use popsicle sticks because I think that they work a little bit easier because they're a little bit more bendable to get the shapes right. So we can start by laying one popsicle stick in front of us and putting 2 sticks across it just like that. Next, we'll put another one just over the top of the 2 sticks we laid down. Now here is where you have to pay extra close attention because this part can be a little tough without a lot of practice. We're going to take our next popsicle stick and it goes over the top stick and under the bottom stick. I'm just going to get it started so that I have 2 of them ready to go, and then I go ahead and slide them forward into place. The next piece I'm going to do is take another popsicle stick and I'm going to put it underneath the 2 sticks that I just placed down. And just like before, it will take 2 more sticks and I will go over the top piece and under the bottom piece. Just like that. Now I'm going to do this a couple more times using the same process that I did before. And all of my sticks now have met in the middle. So I'm going to start over again and go towards the outside of the sticks, just so that I have enough room to keep going. And one more time. I'll do the last one. Now I've created a bridge. It stands up. I can put my hands underneath my bridge, just like that. It stands up under its own weight. And there's a lot more going on here than just tension and compression. There are a whole lot of forces coming together to help this thing stand on its own. Now, popsicle sticks made it easy to build this, but it didn't make it very sturdy. It seems pretty flimsy. If you wanted something that could support a little more weight, you might want to use sturdier objects. Next, I'm going to move this out of the way. Next, we'll take a look at another fun object that has to do with a property called tensegrity. Now, this might be a little difficult to see, but what's going on here is that this top piece is being held up entirely by strings. Now, as we learned before, strings don't have the ability to hold an object up under compression. So let's try to figure out what's going on here. In this example, the top piece here has a little hook coming down, and it's got a string connecting it to a hook that's above it from that bottom piece. That string in the middle is actually pulling upward on the top piece, creating tension to hold this whole thing up. And that's how tensegrity gets its name. It's tension integrity, and it's also sometimes called anti-gravity structures. Now, to build a structure like this, you'll just need a few popsicle sticks, and you'll want to glue them in the shape of you'll want 2 triangles, and I've made a little hook shape here. You'll want 2 of these little hooks as well. If you attach the hook to the corner of each triangle, just like that, you should get a final shape that looks something like this. Once you have those 2 shapes, you'll have to attach the string to the center here. That's what's going to hold all of the weight of the object. And then the outside is just so that the object doesn't collapse on itself. It kind of creates a balance between all of the corners. But if I were to cut the center string, the whole thing would just fall apart. This can be a little tricky, and it's okay to ask for help from a sibling or parents. if you were to try to do this by yourself, you might have to practice some patience, some persistence, and most importantly, you'd want to stay positive. I hope you enjoyed learning about compression and tension with me today. And if you have an interest in engineering, you can ask your parents or your teachers or even your librarian for more resources about other engineering topics. And if you made your own activities like the ones that we showed you in this video, please share them with us on our Facebook or our Instagram, or you can just send us an email. Thank you for watching my video, and I hope you enjoy the rest of your day.